Welcome to this video where I will be showing you how to extract boundary condition independent reduced order models in Simcenter Flotherm 2019.1. Reduced order modelling is an approach to derive a dynamic compact thermal model from a thermal simulation model. A model is BCI if it predicts temperature in space and time with the same level of accuracy regardless of the thermal environment in which it is placed. A BCI-ROM will enable extremely fast transient solutions while retaining high accuracy in all situations. The BCI-ROM extraction method in Simcenter Flotherm is an extension of the fantastic method. For more information on this method, refer to the validation documents on Support Center and the following literature. Here is a conduction-only model with two sources and ambient attributes attached to all faces. To export a BCI-ROM, select Project, Export Project, BCI-ROM. In the BCI-ROM Preferences dialog box, define the requested acceptable relative error. The default value of 0.001 is recommended for most applications. The HTC range sets the heat transfer coefficient range that is exercised for all ambient attributes attached to the model, either through the solution domain faces or through cutouts. The default range of 1 to 10,000 watts per meter square Kelvin is used for Delphi model generation in Simcenter Flotherm Pack and is well suited for package level applications. Navigate to a folder and click Save. The solver runs in order to create the export files. The Thermal Netlist/BCI-ROM export progress dialog box is displayed, showing a percentage progress bar. Note that a CFD solution is not created. When the export has finished, an info message is displayed. The reduced order model is exported in the form of a zip file which contains star.mtx, matrices defining the ROM, report.rom, a brief report of the result of the extraction process including achieved relative error, rom_parameters.m, a script compatible with mathematical programming tools such as Matlab and GNU Octave that provides a means to set variables of interest when solving the BCI-ROM in these tools. Now we'll move on to solving the extracted BCI-ROM in Matlab. Unzip this folder and place the BCI-ROM in the desired location for solving. The solver harness available from Support Center contains several scripts that are used to solve the BCI-ROM and produce plots of the results. The main script that drives all the Simcenter Flotherm version 19.1 is called rom_start.m. This is the starting point for all BCI-ROM solves and the only file in the solver harness that requires modification. The key setting in rom_start.m is the project to be solved. The path to the folder containing the BCI-ROM files should be specified as in the example shown. Note the relative paths are supported. Within the BCI-ROM, open rom_parameters.m. This is a script file used by the BCI-ROM solver harness to set the following parameters for the ROM solve: duration of the transient, heat transfer coefficient values for each ambient attribute, ambient temperature for each ambient attribute and initial temperature, power as a function of time for each heat source. When Simcenter Flotherm creates the rom_parameters.m file during BCI-ROM extraction, it will include several values from the original model: the heat transfer coefficients for the attached ambients, the power dissipation for each heat source. The global ambient temperature is written as the temperature for all ambient attributes and the initial simulation temperature. Note, if transient variations of power are defined in the Simcenter Flotherm model, these are not included in the rom_parameters.m file. They can be added, however, as per the instructions in the rom_parameters file. More detailed information on these settings can be found in the BCI-ROM solver harness PDF, available in the download from Support Center. Save the changes to the rom_start and rom_parameters file. To solve, run the rom_start file. The ROM solver harness is configured to create 4 charts by default, following ROM solve completion. 1. Probe temperature versus time. The probe temperatures are centroid temperature for every heat source in the Simcenter Flotherm model and temperatures for every monitor point in the Simcenter Flotherm model. 2. Surface heat flows versus time. Each curve on this chart is the heat moving through the collection of faces associated with the ambient attribute in the Simcenter Flotherm model. A curve for the total heat flow is also included. 3. Mean surface temperature versus time. Each curve on this chart is the average surface temperature for the collection of faces associated with an ambient attribute in the Simcenter Flotherm model. 4. Source power versus time. Each heat source in the Simcenter Flotherm model is represented with a curve in this chart. Note, these default charts are defined in the rom_plot_probe file. This file can be modified to customize this behavior if desired. The temperature and heat flow data are written to CSV files in the folder containing the BCI-ROM files. The file names are probe.csv and hflows.csv. The full result set is available in the Matlab workspace named Out, following a ROM solve as well. Stored in the Out workspace are the following fields which can be copied into other tools if desired for further analysis or plotting. Lowercase t_hat, time steps, y_hat, a vector in the ROM space used during the extraction process, uppercase t_hat, probe temperatures, h_flux, surface heat flows, t*, mean surface temperatures, and sources, heat source power dissipation. Thank you for watching this video. For more information, please go to our website.